All right, hey everybody. In today's video, we are going to be learning how to solve two-step inequalities, which actually isn't going to be too bad because it's very similar to solving our equations because we still use the inverse operations. And what I mean by inverse operations is if like you see a negative constant, we do the opposite by adding. And when we see multiplication here with a coefficient, we do the opposite by dividing. All right. Now, friendly reminder here that when we have a coefficient that is negative, we need to flip our inequality sign. So let's kind of dive on in here and just review the steps to solving our two-step. We're going to drop the line and focus our attention over here. And I see a 7n and then a -4. I have a negative constant and I have a coefficient of 7. So to solve, we're going to add 4 to both sides. And 10 plus 4 is 14, so I'm going to get a 14 over here. This cancels out, and I'm going to bring down a 7n. Now, since I see multiplication, I'm going to do the inverse operation, which is now to divide. So I'm going to divide both sides by 7. So basically, you guys can see that this is exactly like solving an equation, except now we're going to have an inequality symbol instead of an equal sign. So here, n is greater than 2. Now, on a number line, we're going to put a 2 here, which means that 3 would be on this side, and that means 1 is over here. So we'll have an open circle on 2, and since n is greater than 2, we will shade in this direction. So at this point, you should have taken notes on how to solve this two-step inequality. This is the answer that we got, and we graphed the solution here on a number line. All right, now let's try another one. So we're going to drop our line just like we're used to. And this time I have a 4, which is my constant, and then a -3 is my coefficient. So I have a positive number here, so I'm going to start by subtracting 4 on both sides. And 25 minus 4 is a 21. Now 4 minus 4 cancels out, and we're going to bring down here a -3x. Don't forget the negative, okay, the -3x, so don't forget that there's a negative there. And this time, y'all, we have a coefficient that's negative, so when we divide right here by both sides, we are going to need to remember to flip our symbol. So if the symbol was originally like a greater than or equal to, we're going to turn it around to be a less than or equal to. X is on this side. And over here, 21 divided by a -3 is -7. And again, you always have your calculator to do that math. There's the 21 divided by the -3 and there's the -7. So this is the answer that we get. Now let's build our number line with the negatives. We got a -7 here. Careful, that means that the -6 is on this side because we're getting closer to 0. And then this side we're getting smaller, so here's the -8. All right, this time we're going to have a closed circle because it's or equal to. And we're going to shade less than, so we're going to shade in this direction. Okay. All right, and then now here for the next one, when we drop our line, we have a negative constant, so we're going to add 5. We're going to add 5. And this cancels out, and so I'm going to bring down the y with a denominator of 3. And over here, -10 plus 5, just be careful with that. -10 plus 5. If you've got a 10 that's negative and you add 5, you're at -5. So that's where I got my -5. Now, when we see a denominator, what we're supposed to do is multiply now. So we're going to do the inverse operation of this division, which is to multiply. And so now we're just going to multiply -5 by 3. And -5 times 3 is going to be a -15. I did not have a negative denominator, so I do not need to flip. And I'm going to keep the less than that I see in the problem. This cancels out, so I've got y is less than the -15. And now on my number line, here's the -15. Because we're in negatives, we just got to be careful. This would be a -14. This would be a -16. All right, we're going to have an open circle because it's just y is less than. And we're going to shade everything that would be less than the -15. So in this video, I just wanted to review with you guys how to solve the two-step and then when to flip. And now you can see we're really just putting everything together from how to solve with the equations. You know how to graph on the number line. So we're just kind of putting everything together, and you know when to flip if you have a negative coefficient or a negative denominator. So let's take a look at this one. Now with this one here, when we drop our line, we have a +6. So we're going to start by taking away 6 on both sides. Now with this, You might remember from a long time ago that anytime we see a negative out in front, we're going to put it down with the denominator so we don't forget about it. So I'm just putting the negative down here. Now on this side, if you have 2 negatives and 6 more negatives, you have 8 negatives. Okay. Now when we have a denominator, we multiply both sides by that denominator, and this time we do have a negative number, so we do need to flip. This symbol was a greater than or equal to, so now it's a less than or equal to. Okay? All right, now I'm going to cancel this out, and m is over here. And a negative times a negative is positive 24. So we flipped the symbol because we had a negative denominator. All right, so here's my 24. We'll put a 25 here. All right, we got a 23. And so we're going to have a closed circle on the 24, and everything less than we would shade this way. Now back in the equations packet, we talked about what to do if you see a constant up top with your numerator. If your constant is up top with your numerator, the first thing you actually want to do is to get rid of this 15. So our first step here is going to be to multiply both sides by 15. Hopefully that rings a bell from our equations unit. So now this thing, the negative 9 plus a, I don't need to flip my symbol because see how I didn't have a negative denominator? If this was a negative 15, y'all, then I would need to flip the symbol, but it's not, so I don't need to flip. And then over here, this is a 15. So I'm going to keep my symbol the same. And now I'm just going to add 9 and add 9. So a here has to be greater than, on this side we get a 24. So a is greater than 24. So here's a 24, similar number line to what we just built over here. We'd have a 25 on this side, and then we have a 23 over here. So for greater than, we're going to have an open circle, and we're going to shade this way, so there's a is greater than 24. Here's another one quite similar, where again you have a constant in the numerator. So for this one, let's get rid of the 21 first. Let's get rid of that denominator first. We're going to multiply both sides by the denominator. It's not negative, so I'm not going to flip my symbol. I'm going to leave it. Over here, I get a negative 21. And over here, this cancels out, and I just have v minus 2. Now we're going to add 2. Add 2. This cancels out, and so v is going to be less than or equal to, and on this side, just be careful, you've got your 21 that's negative, and you're going to add 2, so you're at a negative 19 there. Some people would have thought you're at a negative 23, but nah. All right, cool, so here's going to be the negative 19. Careful when you're building that negative number line, here's the negative 18, and then this is a negative 20. All right, cool, so for v, it's going to be less than or equal to the negative 19. So I'm going to have a closed circle because of the or equal to, because of that line right there. And for less than, everything is going to be this way. V is less than the negative 19. All right, we just have 3 more here on this page with you guys. So I just wanted to model all the different types of two-step equations. That's basically all I'm doing here is just kind of reviewing all the different things that you could see that would require 2 steps to solve. So here, when you see a fraction for your constant, just think of it as a decimal. And so if you have a positive 0.5 right there, you're just going to do minus 0.5 on both sides, minus 0.5. So a half minus a half cancels out. I'm going to bring down my 2x. 5 minus 0.5 is 4.5. Now we're going to divide by 2. It is not a negative coefficient, so I'm not going to flip my symbol. I'm going to leave the symbol the same. I got a greater than or equal to. And if you had $4.50 and cut that in half, you would have $2.25. So for this one, we get that x is greater than or equal to 2.25. Now for the number line, you have a couple of different options. If you put a 2 here, and that means we have a 3 here, and then a 1 here, you just need to estimate that 2 1/4. Like if you broke this up into 1/4, 2/4, 3/4, the 2.25 would be right here. So we're just estimating. and then greater than, we would shade in this direction right here. So you could kind of estimate, or on a number line, what you could do, I'll just show you guys real quick. I'll just sketch right below it. You could say this is a 2 and this is a 3. So that means that this would be like 2 and a fourth, 2/4, and 3/4. And then again, right there would be the 2.25. Okay, and then shade this way. All right, cool. So you might see a constant that's a fraction, and that's okay. Just make it a decimal, and you can do the opposite by adding or subtracting. Now I wanted to review because now you see in the next problem, see how we have a fraction still, but this time the fraction is the coefficient. Now our constant is the 8, so we're going to subtract the 8 on both sides. So the 8's cancel out, and I'm going to bring down my 2/5 x. And now 14 minus 8 here, we're going to get a 6. Now y'all might remember, if your fraction isn't the constant, but the coefficient, now is when you care about the reciprocal of 5/2. Now we care about the reciprocal of 5/2. So I have an x. This was not a negative coefficient, so I do not need to flip the symbol. I'm going to keep it the exact same direction. And over here, I'm going to do 6 divided by 2, which is 3, and then times 5 is a 15. So x is greater than or equal to 15. Now, you could just do 5/2 in the calculator, and then just do times the 6, and we still get a 15. All right, so let's put this on the number line. This one should be nice and easy. We get a 15. This is going to be a 16. Here we have a 14. And if we're shading greater than or equal to, it's a closed circle, and we're going to the right. Alrighty, we have one last one here. So we've got a negative coefficient, that's a decimal. We have a positive constant, and over here we have a 1 4/5. So I want to remind you guys that 4/5, if you did a 4/5, that's 0.8. So this is really a 1.8 over here. Now, when you have the negative 0.4x, and then you have your plus 1, everything here is in decimal form, so you can use your calculator. We're going to take away 1, and this is going to be a 0.8. And then over here we have a negative 0.4x. Now I'm going to divide both sides by this negative 0.4, and since I have a negative coefficient, I do need to flip my symbol. So this symbol was originally a greater than or equal to, so now it's going to be a less than or equal to. And then I have x is less than or equal to, and let's see what happens when we do this 0.8 divided by the 0.4. That was negative. We get a negative 2. So x is less than or equal to negative 2. And my number line, since I'm just kind of running out of a little bit of room, I'm just going to kind of white out that number line right there and just move it down a little bit. All right, sweet. So I'll graph it on the number line right here. So we have a negative 2, which means negative 1 is this way, and negative 3 is here. So we're going to do a closed circle on the negative 2. And if it's less than, we're going to shade in this direction. Okay. So we just covered how to solve all the two-step stuff. Real quick, let's flip over. I don't want you to forget how to solve one-step inequalities when you see the fraction. I want to go back to the fraction thing, okay? And I want to review when you just had one thing to do if you saw a fraction. In this problem, the fraction that we have is a constant. So if you only see the fraction as a constant, you just need to add it on both sides. So you're going to add the 2/3 on both sides. Now, if we take a negative 6 and we try to add the 2/3 to it, y'all know that 2/3 is a 0.66666666 repeating. So we basically are going to get a negative 5 1/3. This only happens because I stopped in the calculator. I didn't have it keep going. But you can see we get a negative 5 1/3, a negative 5 1/3 for this one. So why? So this cancels out. I don't need to flip my symbol. And this we said was a negative 5 1/3. If you're at negative 6 and you add 2/3, you're at negative 5 1/3. So over here, if we let this be a -5, that means that this is -6, and this is a -4. So -5 and a third, if you're at -5 and go back a third of the way, you'd be like right here-ish. And for less than or equal to, we'd go this way. So that now shows that y is less than or equal to a -5 and 1/3. And again, I just wanted to point out that if you only had one step and your fraction was the constant, this is what you do. Now, if your fraction is the coefficient, like in this one, this is when you cared about its reciprocal, the -2/1, and then the -2/1. So over here we have a -8 times a -2, which is a +16. And y'all, this time because we had a negative coefficient, I do need to flip my symbol. And so y here is going to be greater than 16. Now on a number line, we can put the 16 here, which of course means that's going to be a 17, and then 15's here. Notice today in the video, I'm not making y'all fill out all the number line stuff because I think you guys get the hang of it. But here we're going to have an open circle, and greater than 16 is going to go this way. Okay? All right, so that just reviewed what to do with the one step if you saw a fraction. I just wanted to review if it was a constant versus if it was a coefficient. And these last three are actually me just reviewing a certain way that the question can look, where you might have to select all values for something that'll make it true. So the first thing I want to point out for this question over here is we have a -11 plus n divided by 3. So we have a constant, y'all, in the numerator. So since we have a constant up in the numerator, I actually care about the 3 first. So I'm going to multiply both sides by the denominator of 3. I did not have a negative denominator, so I don't need to flip. Now the 3's cancel out here, and I bring down my numerator. And on this side, a -2 times 3 is a -6. Now I'm going to add my 11 from this side, and I'm going to add my 11 here. Now -6 plus 11 is +5. I do not need to flip the symbol at any point. So now what we're saying, y'all, is n can be anything as long as it's less than 5. So over here, let's go pick the stuff that's less than 5. A negative number is certainly less than a positive. Here's another negative number. Now 24 we're not going to pick, and 5 we're not going to pick because those values are not less than 5. Okay? So notice if you have this type of problem, you still just solve it as is. And then based on the answer over here that shows all possible solutions, you come over here and just pick a few. All right, the next one. If you saw x minus 3/4 is less than -7, that 3/4, you can just make it a decimal so that you can use your calculator with the 0.75. All right, so we're just going to add 0.75 on both sides here. So notice I just kind of made it a decimal. The decimals cancel out. I have x. I do not need to flip the symbol at all. And here, if you use your calculator for the 7 that's negative, and you add a 0.75, you get -6.25. -6.25. So we want to find anything over here that is smaller than the -6.25. All right, so -20. Remember, if you're looking for stuff that's smaller and negative land, you want it to get more negative. -12 would certainly work. We're not going to pick the -6.25 because it doesn't have or equal to. And that does look a little bit sloppy. Let me just kind of clean up the way that looks. Sorry about that. So we're looking for stuff that was, we said, smaller than a -6.25. All right, now -650 would be further away on the number line. The positive numbers we don't want to pick because those would be bigger than. And now we're on the last question here for the video. Again, when you see that the constant here is a fraction, it's okay to just make it a decimal just like we did up here. And now when you drop your line, you're going to see that you are going to subtract a 0.5 on both sides, so minus 0.5. That cancels out, and I'm going to bring down my 4y. Now $10 minus 50 cents would be $9.50, so 9.5. My coefficient here is a 4. It's not a negative number, so I don't need to flip anything. So I'm just going to leave this symbol here. We've got a greater than or equal to. And now let's use our calculator to do a 9.5 here. and we're going to divide that by a 4. So 2.375. We want anything that's bigger than 2.375 or equal to, anything that's bigger than or equal to 2.375. Now 40 is certainly larger, but we don't want to pick the negative. 2.625 is bigger than 2.375, and we won't pick this negative. So if you ever see questions like this, you could just solve as is, and based on the answer that shows all answers, go pick the few that would work. And that concludes the video for how to solve a two-step inequality. Thank you for watching.